Hi, CC family. So I'm going to be doing the candy probability from cycle 3, week 20. This experiment is all about sampling. Sampling is the goal of figuring out a probability of something by only taking a few select samples. And then we infer the results from the samples of what the whole group must be like for the probability. So the CC book says we're going to use 100 poker chips. I am not going to use 100 poker chips in this example just because I want our brains to wrap around the experiment. You totally can use 100 poker chips. You can use M&Ms if you're that cool teacher and let the kids eat the M&Ms or jelly beans, whatever you want. The larger probably will make it a little bit more challenging, so try to limit yourself to that 100 like the CC book does say to do. I am actually going to use 12 of these. Let me go to my camera. I don't know what these are. They look like pound signs, but they're not quite there because they're missing a little thing, and they connect together. They're really fun. So I'm going to use 12 of these. I have 3 colors that I am using in this hat. I have a red color, I have a white color, and I have a green color. Now, in order to find out what is the ratio, what's the probability that I'll draw a red, or what's the probability I'll draw a white, what's the probability I'll draw a green, we can sample by pulling some out. And what CC wants us to do with our classes is we are going to make a chart, and we are going to talk about our draw. We are going to draw a certain number of times. Remember, I only have 12 in here, so once I draw 12 times, that's it. My hat is empty. We are going to be looking for white, which I'm going to denote with a W. We are going to be looking at red, and we are going to be looking at green. I don't think I told you guys the probability yet, so we're going to figure it out. On my first draw, I am going to dig into my hat. Any opaque bag that you can't look through is ideal, so kids aren't like, ooh, I know what you're getting. And I got red. So what I am going to do to fill out in my chart is I have 1 red is the 1 outcome out of my first and only draws for my total number of draws. I had 0 white and I had 0 green because I'm only drawing 1 at a time. So the draw was a red. Now I'm going to draw again. And this is where that chart might be confusing to some people if you're looking at it for the first time. Ooh, I got red again. I actually kind of think that's exciting. So we have a number 2 draw. Again, it is a red. So I have 0 white out of 2 draws. So my denominator for this statistic is saying right now the probability of white being in this hat is 0. The probability of red is I have had 2 out of 2 draws, so 100%, this whole hat is filled with red based off of this sample, and there are 0 green out of the 2 draws. Now, I said to you, and hopefully I wasn't lying, that there's 3 colors in here, so we're going to go again on our third draw, and in our denominator, it's going to be out of 3 draws. Do note, I've been putting my little pieces off to the side. Do not put them back into your bag because if you replace it, it's going to ruin the sampling experience. So I'm digging. I looked, so I'm going to try to look away. And, ooh, I got white. So now my draw is a white, and I have 1 white out of 3 draws. So maybe 1/3 of the time I get white, 2 out of the 3 draws are red, and there are 0 greens in this bag currently with my sample. They don't exist. Not putting it back into my hat, just putting it off to the side, right? And we could go again. Now, you might be going, oh, how long are you going to continue drawing here? Aren't you going to stop at some point? Especially if you are working with 100 poker chips. I personally wouldn't sit for watching 100 chips being drawn. That's why sampling stops at a certain point. There is a lot of different rules in mathematics to determine what's the right sample size. In my master's program, I learned that the rule of large numbers, 30, was like the beautiful magic number. The book, the foundation textbook, says multiply the last fraction for that color in your chart times the total number that you tell the students. I'm not a huge fan of that being the number of draws that we're going to have. But again, statistic has a lot of wiggle room where we could kind of just go with whatever feels right. If you want to go ahead and tell the students, like, I have 100 poker chips in this bag, how many do you think we should draw so we have a good sample? Do that and see if they get really close to the ratios of what colors are in there, and see if their guess gets a good amount. Again, probability can still be flaky. You might draw all red like I did in my first beginning, and it would skew the results and saying you didn't have enough sample size. So you do want a large enough sample size. I drew white again, so this is the fourth draw. I have 2 out of 4. If you want to reduce your fractions, do so. I'm not going to, because it's going to help me see 1 draw, 2 draw, 3 draw, 4 draw. I have 2 out of 4 here, and I still have no green. Poor green is not doing so hot. All right, so I'm going to draw again. I got red again. So I got my 5th draw. Probably should have written a little smaller, but hey, life is good. We have 2 out of 5. We have 3 out of 5, and still 0 out of 5. You can continue drawing. I have only 12 in here. So because my my bag has such a few amount, I actually really do need to continue drawing probably 8 times in order to get an accurate ratio to appear of how many white, how many red, and how many green I have in here. And that's because I chose a very small amount to put in my hat. That is why using 100 or something very large will be better for the class, so that you can do a smaller sample draw. You are going to draw for quite a bit, at least 30. Oh, I got green. I'm so excited. So for our 6th draw, I got green. So I have 2 white out of 6 draws. I have 3 red out of 6 draws. And I have finally 1 green out of 6 draws. I've actually met my ratio. This is exactly what I have in this bag. I'll go ahead and spoil the magic now. And that's just because I knew the result. I have 1 more red hanging out for me. So I had a total of 4 reds. I had 6 whites. All right. And I had 2 greens. Ooh, I swapped white and red in my head. I should have kept drawing. So in order to make it more accurate to my ratios, you want to get that probability. I'm going to go to another page real quick. So you're going to have, let's say I did draw all 12 times. Let's say time passed, I did 12 draws, and that was all 12 of my things. Whatever my last draw, let's just say it was green for fun. We have... should be, for me, I should have 6 of the white out of 12. I should have 4 out of the 12 for the red. This is white, red. And finally for the green, I should have 2 out of 12. Be kind to yourself. If you are not doing 100, try to make sure however many objects you have is a nice fraction so you can divide easily. I highly recommend multiples of 10, like 10, 20, 30, 40. Don't do 10, it's too little. As you can see with 12, I almost had to draw my whole bag before I got a pretty accurate result. And even then I stopped too soon because I swapped in my head those colors. And then go ahead and tell the kids roughly what their percentages are. You can convert fractions to percents. It makes it a little bit easier. I shouldn't have a wobbly. This should be a set straight one. We should have 1/2, which is exactly 50%, was white in here. And then we have 4/12, which is 1/3. Now this, when you convert him into a percent, is going to be rounded. You can follow whatever rounding rules you want. Just make it like easy for the kids. If you round down on one, you might have to round up on another so that you can show to them at the very end. We are going to have, let me do a roundabout. These guys get close to 100%. So when I add these guys up, they should add up to 100%. And that's what probabilities always have, where they're out of 100. So for your sampling, I think a great question to get the scientific method thinking in kids is ask them how many draws are needed for us to sample whatever you're working with. For mine, I think I probably should have kept going to 8, and I shouldn't have stopped so soon, but I got excited. It could happen to you guys in your class too. Try to be reserved. So have fun.